If you're a PC enthusiast, you probably know that the main way that our PCs, our phones, and our consoles have gotten faster over the years is through shrinking transistor sizes on our processors. Indeed, we have gone from using 250 nanometer chips in the mid-1990s to just 7 nanometer models today. And that number is expected to keep shrinking. But this was not achieved simply by taking the exact same transistor design and shrinking it every couple of years. Instead, engineers have had to get creative with how to build transistors in order to pull this off. As we touched on in our video about processor nodes, which you can check out up here, one major innovation was FinFET. This is a type of transistor in which the channel the electrons move through is raised up off the substrate, kind of like a shark's fin, increasing the surface area and allowing more electrons to flow. But now we're getting to the point where FinFET is reaching its limits in terms of how tightly we can pack the transistors together, which means the industry is going to need to move to a new transistor design for future generations of high-performance chips. Enter Gate-All-Around. A super boring name for a super cool update to the FinFET concept. Similar to FinFET, the channel is raised up off the substrate, but instead of being one large fin-like piece, it's broken up into several pieces called Nano Ribbons. To find out more about these Nano Ribbons, we talked to our friend Jack Cavaleros at Intel, and we'd like to thank him, along with Bruce Feinberg, Marissa Ahmed, and Ben Benson for helping us with this episode. So gate-all-around design increases the surface area so that the gate that controls the current flow surrounds the nanoribbon on all sides, hence the name gate-all-around. This is hugely important for a few reasons, actually. You see, the gate's ability to control current depends on the physical size of the channel, and a single, bulky fin can be hard to control. At present transistor sizes, it's not a huge problem, but if we kept shrinking FinFET transistors even further, the lack of control would introduce leakage, which would interfere with and possibly corrupt your data flow. But with gate-all-around, the smaller nanoribbons means the gate has a much easier time controlling the current flow, allowing for more tightly packed transistors. On top of that, you can stack the nanoribbons. See what we did there? Which takes up less space than adding more fins in FinFET, which required you to put the fins next to each other instead. Another big advantage is that if a certain processor design requires more power, you can simply make the nanoribbons wider laterally. With FinFET, each fin could carry a discrete amount of current. So if a design needed, say, 5x current, but each FinFET could only carry 2x, you'd have to have 3 fins with a capacity of 6x, a design that wasted space. However, you can make a nanoribbon just as wide as you need, saving valuable room on the transistor. And the best part is that you don't need super exotic materials in order to pull this off. It can be done with a silicon germanium alloy, which is way more basic than it sounds, meaning that it shouldn't be too difficult for large chip makers to produce gate-all-around chips in bulk. On that subject, when should we see gate-all-around transistors hitting the market? Well, it should be within the next 5 years across all vendors, but it'll probably appear in data center and server applications before it trickles down to consumers, like you and me. But once it does, we're gonna see the expected benefits that we're used to with smaller transistors, like faster computing, better battery life, lower power consumption, and an ability for devices like laptops and phones to better handle tasks without having to rely as much on cloud computing. I wonder how much better it might make our games as well, assuming we can get nanoribbon GPUs from someone other than an eBay scalper when the time does come. Big thanks to Ren for sponsoring this video. Ren is a website where you calculate your carbon footprint and then offset it by funding projects that plant trees and protect rainforests. Just by answering a few questions about your lifestyle, you can see what your carbon footprint is and how you can reduce it. No one can reduce their carbon footprint to 0, but you can offset what you have left after trying your best. Once you sign up to make a monthly contribution to offset your carbon footprint, you can then receive monthly updates from the tree planting, rainforest protection, and other projects that you support. You get to see the trees you planted and what your money is actually spent on, so click the link below and help the climate crisis today. So thanks for watching, guys. If you liked this video, hit like. If you subscribed to this video, hit subscribe. What? And be sure to hit us up in the comment section with your suggestion for topics that we should cover in the future.